Hey everyone, welcome back to the channel. Today we're diving into episode 17. And we're talking about something truly transformative for how you build and run applications, Docker Compose. If you've been following along, you've probably gotten pretty good at building and running single containers. But here's a secret. Most real-world applications aren't just one single program. They're more like a fleet of trucks, each with a specific job, all working together to deliver something valuable. Think about a modern web application. You've got your main backend service, sure. But you also need a database to store data, maybe a Redis cache for speed, a message queue for background tasks, and a separate front-end application. Suddenly, that one simple program has turned into a whole collection of services that need to talk to each other. This is the world of microservices, and this is where the real complexity comes in. It's not just about building each individual service. The hard part is managing the transport and contracts between them. How does your backend find the database? How do they communicate securely? What happens if one service goes down? Manually managing all these connections is a recipe for disaster. It's confusing, error-prone, and makes development a real slog. You end up spending more time configuring networks and environment variables than actually writing code. This is exactly the problem Docker Compose solves. And to understand it, let's use a logistics analogy. Think of a single Docker container as a single truck. It's self-contained, it has its cargo, your application, and it has an engine to run. That's great for one delivery. But what if you're running a massive logistics operation? You have a whole fleet of trucks. You don't just send them out randomly. You need a plan. That's where Docker Compose comes in. Docker Compose is like the fleet dispatch schedule. It's a single file, usually called Docker Compose. And look, that defines your entire fleet of services. It says, I need one truck for the database, one for the backend API, and one for the front end. It specifies what's in each truck, which Docker image to use, and how they should be configured. But a schedule isn't enough. The trucks need to communicate. Imagine the drivers trying to coordinate by shouting out the window on the highway. It would be chaos. They need walkie-talkies. In our analogy, the Docker Compose network is the fleet's private walkie-talkie channel. When you launch your services with Compose, it automatically creates a dedicated virtual network. Inside this network, your services can find and talk to each other using simple, human-readable names. Your backend can just connect to a host-named database, and Compose handles all the complex networking magic behind the scenes. No more hunting for IP addresses or hard-coding connection strings. So, with one simple command, Docker Compose up, you bring your entire application to life. It reads your manifest, builds or pulls the necessary images, creates the network, and starts all your containers in the correct order, all connected and ready to go. It's like the dispatcher giving the go signal over the radio, and the entire fleet rolls out in perfect formation. Let's look at a practical example. Imagine we're building a simple polling app. We need a Python app to vote, a Redis queue to handle the votes, and a node. J's worker to pull votes from Redis and store them in a Postgres database. And finally, a results app to display the live results. That's 5 different services. Without Compose, you'd have to run 5 separate Docker run commands. You'd need to manually create a network, link them all together, pass in environment variables for database passwords, and hope you got everything right. If you want to shut it down, you have to find and stop all 5 containers. Now, let's see the Compose way. You create a Docker Compose YML file. Inside, you define 5 services: pull, Redis, worker, DB, and result. For each one, you specify the image to use. For DB, you can even set environment variables like the Postgres password directly in the file. For your own custom services like poll and worker, you can tell Compose where to find the Docker file and have it build the images for you. When you run Docker Compose up, it reads this file. It sees it needs a Postgres database, so it pulls the official Postgres image. It sees it needs a Redis cache, so it pulls that. Then it builds your Python and Node.js app images. It creates a network for all of them. Then it starts all 5 containers, connecting them to that network. Your Python app can now connect to Redis 6379, and your node worker can connect to DB to 5432 just by using their service names. It's clean, it's repeatable, and it's all defined in one place. This is a game changer for local development. Every developer on your team can just clone the repository, run Docker Compose up, and have the exact same fully functional development environment running in minutes. No more "it works on my machine" problems. the Docker Compose. IMO file becomes the single source of truth for your application's architecture. And when you're done for the day, just hit Ctrl+C or run Docker Compose down. Compose will gracefully stop all the containers, and if you want, it can even remove the network and the data volumes, leaving your system completely clean. It's orchestration made simple, but what happens when things go wrong? In a system with multiple moving parts, failure is inevitable. A service might crash, a database connection might fail, or a network issue could pop up. Debugging these kinds of distributed systems can be a nightmare. How do you figure out which component failed and why? This is where the power of Docker Compose really shines beyond just starting things up. You can easily view the logs from all your services in a single aggregated stream. Or you can tail the logs of a specific service to isolate a problem. You can even attach a shell directly into a running container to poke around, check network connectivity, or inspect its file system. Let's say our voting app isn't showing any new votes. Where do you start? With Compose, your first step might be Docker Compose logs worker. You might see an error message saying could not connect to database. Ah, clue. Next, you could check the logs for the database container with Docker Compose logs DB. Maybe you see it's complaining about a password authentication failure. You check your Docker Compose YAML file and realize you have a typo in the password environment variable. You fix it, run Docker Compose up, force recreate, and everything springs back to life. This ability to easily inspect and interact with each part of your system while managing it as a whole is what makes Compose an indispensable tool. It turns a complex, distributed system into something manageable and debuggable. So to recap, real-world applications are often composed of many services. Docker Compose allows you to define, run, and connect this entire multi-container application using a single configuration file and a simple set of commands. It simplifies networking, streamlines development workflows across teams, and provides powerful tools for debugging your distributed system. It takes the chaos of managing a fleet and gives you a clear, powerful dispatch control center. In our next episode, we'll take this a step further and explore how to manage persistent data with Docker volumes and how to use them effectively within a Compose setup. You won't want to miss it. Thanks so much for watching. If you found this helpful, please hit that like button. And if you haven't already, subscribe for more content on Docker and modern development. See you in the next one.